Welcome to free online maths lessons by the Maths Online Tutor. Today I'm going to teach you about vectors. A vector describes the movement from one point to another. For example, these two line segments represent two vectors, the movement from point A to point B and the movement from point C to point D. A vector quantity has both direction and magnitude. Magnitude means the size. So if we measure the distance between point A and B, we will find out the magnitude of AB vector. If we measure the distance represented by the line segment CD, then we can find the magnitude of vector CD. The arrow of each vector shows what the direction is. So remember that a vector quantity always have a direction as well as the magnitude. A scalar quantity, on the other hand, has only the magnitude. There is no direction. For example, a distance traveled is 20 meters. There we only have the magnitude. There is no direction. So it is not a vector. We call it a scalar. A vector can be represented by a line segment labeled with an arrow. There are two methods that we can use to represent a vector. We can use the column vector method, or we can use the line segment method and then show the magnitude of the vector. The column vector method has two coordinates, x and y coordinates, inside a pair of brackets. The top number represents how many to move in the positive x direction, and the bottom number represents how many to move in positive y direction. Vectors are equal if they have the same magnitude and direction regardless of where they are. For example, the figure on the left shows two vectors, the CD vector and EF vector. So by definition, what is meant by a vector is that we can move from point C to D following another path. It could be by moving from point C to here on the positive x direction and then move towards point D in the positive y direction. This is the same as moving on a straight line from point C to D. So the x translation is one grid on the positive x direction and the y translation is 1, 2, 3, 4 grids in the positive y direction. This is the same translation for EF vector. However, these two vectors are at two different locations. As I mentioned earlier, the two vectors can be equal regardless of where they are, as long as they have the same amount of movement followed by the same direction. Therefore, in this case, CD vector is equal to EF vector. When we write a vector using the starting and end points, we use capital letters or the labels of the points, and then above the letters we use an arrow to represent that it is a vector. Without this arrow, it is just a magnitude, not a vector. So it is important that we always use the arrow. Okay, the other method is to use a line segment and then above it write the magnitude. So in this case, I do not have the starting and end points. I only have the magnitude. The magnitude is k and the direction represents that this is the direction to follow. So the vector actually moves from here to here, and the direction is represented by the arrow. The magnitude is k. On the other hand, this other vector, it has the opposite direction to this vector. So this vector has a magnitude of minus k in the opposite direction. These two vectors are not equal. It's because they are not in the same direction. So a negative vector has the same magnitude but the opposite direction. Vector minus k is the same as traveling backwards down on the vector k. Okay, let's now try an example question to improve our understanding. In this question, write in terms of A, B, C the vectors zy, yz, za and bx. What are A, B, C? A is the magnitude of ax vector. Magnitude means the size. So ax vector is equal to A. Az vector is equal to C. And xz vector is equal to B. So remember, we must understand the starting and end points using the arrow. In this case, the arrow goes in this direction for xz vector. Therefore, the starting point has to be x and the end point has to be z. Let's find out the value of zy vector. Ax, yz is a parallelogram. So as you know, in a parallelogram, the opposite sides are equal and they are also parallel. So this gives us an important hint. That means zy is parallel to ax. Therefore, zy should follow the same direction as ax. In a parallelogram, as I mentioned, the opposite sides are equal as well. So, zy will be equal to ax. Now I know that zy is equal to ax and also has the same direction as ax. So zy vector is equal to ax vector. Therefore, it is equal to A. Let's find out yz vector. Yz, the starting point is y and the end point is c because it's asking for the yz vector. The starting point is y and the end point is c. Okay, so xy cz is again a parallelogram. So as I said, in a parallelogram the opposite sides are equal and parallel. So the yc will follow the same direction as xz. And as in a parallelogram the opposite sides are equal, yc is also equal to xz. So yc is equal to b. Now let's find out za vector. So on za vector, the starting point is z and the end point is a. From here to here, we know az vector. When the starting point is a and the end point is z, az vector is equal to c. za vector is in the opposite direction to az vector. Therefore, za is the negative vector of az. za therefore is equal to minus c. Okay, now let's find out bx vector. Bxzy is a parallelogram. On a parallelogram, opposite sides are equal and parallel. We have already found out zy vector. Zy vector is equal to a. Therefore, xb vector is equal to a as well. However, we need to find out bx vector. Therefore, bx vector is equal to minus a. Okay, now I am moving on to vector arithmetic. Here in this topic, I am talking about multiplying vectors by a scalar. Vectors can be multiplied by a scalar. We change the size of the vector but not the direction. As you already know, a scalar means a quantity. It doesn't have a direction. So if you have a particular vector and then multiply it by a scalar, all it does is either increase or decrease the size of the vector but does not change the direction. Here I have the vector k. The column vector of vector k is 3 and minus 2. So 3 means there is a positive x translation by 3 grids. 1, 2, 3. And there is a minus 2, which means there is a negative y translation. As you can see, it's going down. So I can go from this point to this point by moving from here to here and then here to here. Okay, the vector 2k is twice as long as vector k. That means there is a scale of 2 applied to vector k. So vector k was multiplied by 2. So double each number in the column vector to get vector 2k. So when I double 3, I get 6, and double minus 2, I get minus 4. So vector 2k is 6 and minus 4. What does this mean? There is X translation of 6 grids. 1, 2, 3, 4, 5, 6. And there is a Y translation of minus 4. 1, 2, 3, 4. Okay, let's do another example. I have the column vector for vector m. It has X translation of 4 and Y translation of 4. So both numbers are positive, therefore X translation is 4 in positive X direction and Y translation is positive 4 in positive Y direction. I have to find out the half m vector. So half is the scalar applied to m. So the column vector m is multiplied by half. In other terms, column vector m is divided by 2. So I have to divide each number in column vector m by 2 to find out the half m. Therefore, half m is equal to 2 and 2. So if I represent this half m vector, then there is X translation of 2 in the positive X direction and Y translation of 2 in the positive Y direction. Okay, let's now talk about addition and subtraction of vectors. There are two methods to follow in order to add or subtract vectors. The first method is that the vectors can be added by drawing the first vector, then starting the second vector where the first vector ends. For example, I have drawn the xy vector. It starts at position x and finish at position y. Then I started the second vector yz at the end point of xy vector and then it ends at position z. So if I add xy vector to yz vector, then I can find the resultant of that. The resultant will be xz vector. This means that I can move from position x to z by following an alternate path, which is from x to y and y to z. What is meant by the resultant? The resultant means the combination of two or more vectors. For example, the resultant of a 30 Newton force up and a 40 Newton force horizontal is a 50 Newton force at 37 degrees above the horizontal. So going back to our example again, if I add xy vector to yz vector, then I can have the resultant of xz vector. This is the first method. Then we can use the column vectors in order to find the resultant as well. So if the xy vector is 4 and 2 and then the yz vector is 1 and minus 4, simply the resultant column vector will be adding the x translations together in both vectors and adding the y translations in both vectors together. So I add 4 to 1 and 2 to minus 4, which is equal to 5 and minus 2. So the resultant column vector is 5 and minus 2. Okay, let's now talk about subtracting vectors. This is very similar to addition of vectors. However, the only difference is that instead of a plus sign, then you can have a minus sign. Subtracting vector is same as adding a negative vector. Okay, the addition of yx vector to xz vector is equal to yz vector. Basically, I can move from y to z following an alternate path from y to x and then x to z. Yx vector is same as xy vector but in the opposite direction. Therefore, yx vector is equal to minus xy. So if I add minus xy to xz vector, then it is equal to yz. What is minus xy vector? I already know from the previous example that the xy vector is 4 and 2. The minus xy then will be minus 4 and minus 2. So if I add this column vector now to xz vector, which I already found from my previous example, which is 5 and minus 2, then it will be equal to minus 4 at 5 and minus 2 at minus 2, which is equal to 1 and minus 4. Okay, let's try one more example on vectors. In this example, we have to write in terms of a and b the vector km. The vector km is not drawn here, but you can draw a line in order to represent the km vector. What we know is OK vector, which is equal to a value of A, and we know also the OM vector, which is equal to B. So OK vector is moving from O to K and OM vector is moving from O to M. So the KO vector is minus A. KO vector is opposite of OK vector. So it will be minus A. The OM vector is B, therefore MO vector is minus B. I have to find the KM vector. KM vector has a starting point of K and end point of M. So KM movement is from here to here. In order to move from here to here, I can use an alternate path. That is from here to here and then from here to here. So if I move from here to here, that is the vector KO, and then from here to here is vector OM. Therefore, the resultant KM vector is equal to addition of KO vector to OM vector. KO vector is minus A. OM vector is B. Therefore, KM vector is equal to B minus A. In this lesson video, I have done all the theory behind the vectors in GCSE curriculum. In my next lesson video, I will be doing more practice questions on vectors. This will cover some advanced past exam paper questions as well. In order to have an update on my next lesson on vectors and also on other topics, please subscribe to my channel. Thank you.